Hello, and welcome to Cruising Through Calculus. My name is Alex, and today we're going to be using the difference quotients to find either the slopes of the tangent lines or the equations of the tangent lines. So let's jump right in. Here it says, find the slope of the tangent line of f of x equals 2x squared minus 5x plus 3 at x equals 3. Now, there are several different quotient formulas that you can use, and for this problem I'm going to be using this version of the difference quotient. You are going to need to have these memorized to answer these questions. So let's jump right in and answer this one here. If you look up at our difference quotient formula, we have f of a and a. Those are going to be the values that we are approaching. So here, a is going to be equal to 3. Now, we need to figure out what f of a is equal to. So in other words, I need to figure out what f of 3 is equal to. And they did give me this function right here, so I'm going to take 3 and plug it in. Let's see what we get. 2 times 3 squared minus 5 times 3 plus 3. Okay, so 3 squared is 9. 9 times 2 is 18. Minus 15 plus 3. Well, if I do 18 minus 15, that is 3, and then 3 plus 3 is 6. So 6 is what I get when I plug 3 in for x. Okay, this is all well and good. Now that I know what a is, and now that I know what f of 3 is, let's plug it into our formula here. We're now going to find the limit as x approaches a, which is 3, of f of x, which is our original function, 2x squared minus 5x plus 3, minus 6, all over x minus a, or x minus 3 in other words. So let's take a look at this here. I see that we have a 3 minus 6, so that is going to give us negative 3. Okay, so we've done that, but it doesn't really seem to have helped us too much, except maybe we can actually factor the numerator here. So let's see if we can do that. All right, let's see if this is indeed factorable. To factor one like this, we got to start with this. 2 times negative 3. That gives us negative 6. Can I find two numbers that multiply to negative 6 and add to negative 5? Yes, I can. That would be negative 6 and positive 1. So now I'm going to take this part here, this 2x squared minus 5x minus 3, and I'm going to change it to 2x squared minus 6x plus 1x minus 3. Now I'm going to see what I can factor from the first two pieces. It looks like I can factor a 2 and an x, leaving me with an x minus 3. And over here, well, there isn't really much to factor, so I'll just say 1 is what I factor out. Ah, this is perfect. I have an x minus 3 and an x minus 3. That can be factored out. So this is what we're going to get here. All right, back to our limit problem here. I factored the top, so let's go ahead and write out what it factored into. We have x minus 3 and 2x plus 1. All over x minus 3. Perfect. The x minus 3 in the denominator here will cancel out, leaving us with just this 2x plus 1. Okay, now, what were we approaching? We were approaching 3 here. So let's go ahead and let's use substitution and plug 3 in for x. We're going to get 2 times 3 plus 1. So that'll be 6 plus 1, which is 7. And because they wanted just the slope of the tangent line and nothing else, that is our final answer, and we're done with our first problem. Here it says, find the equation of the tangent line of f of x equals 2 over x minus 1 at x equals 5. I'm still going to be using this difference quotient here, but on the next couple of problems, we're going to be using the other difference quotient. Let's take a look at this one here. Just like last time, I'm going to figure out what a is equal to and f of a is equal to. A is the number we're approaching. In this case, that is 5. So f of a means I need to plug 5 into our function here. So that's going to be 2 over 5 minus 1, which is 2 over 4, which is, of course, 1/2. All right, let's take this and plug it into our formula. We're now going to find the limit as x approaches a, which is 5, of f of x, which is 2 over x minus 1, minus f of a, which we figured out was 1/2, all over x minus a, so x minus 5. like this. Okay, in order to figure out limits like this is a complex fraction. So what we need to do is look at the numerator and try to get a common denominator. So let's do that here. I'm going to multiply this piece by 2 over 2, and this piece by x minus 1 over x minus 1. So let's see what we get when we do that. Okay, we're going to get 2 times 2, which is 4, over 2 times x minus 1, minus x minus 1 over 2 times x minus 1. And of course, this is all over x minus 5 still. Now notice that the denominators here and here are the same, so I can subtract the top. You have to be careful when you're subtracting with fractions. You have to remember to distribute this negative sign to both of these pieces. So we're going to end up with a negative x and a plus 1 here. Negative x, let's see here, we actually have a 4 at the beginning, don't we? And then a negative x, and then a plus 1. That's over 2 times x minus 1. And then all of that is over x minus 5, like that. All right, this is good because look up here, I have a 4 and a plus 1. So that will turn into 5 minus x over 2 x minus 1 all over x minus 5. All right, this is good actually. Here, let's do this next. We're going to multiply by the reciprocal. So I'm going to take x minus 5 and I'm going to find the reciprocal and multiply by that. So we're going to get 5 minus x over 2 x minus 1 times 1 over x minus 5, like that. All right, now let me take this and move it up here and we'll continue. All right, I've taken what we had down here and I moved it up here. So let's look at this. I would really like to cancel this 5 minus x with this x minus 5, but they're not the same thing. But there's a little trick you can use here. It is actually okay to swap the places of two pieces as long as you do one extra thing. So I can make this x minus 5 as long as I put a negative sign at the beginning like this, which is perfect because now this x minus 5 can cancel with that x minus 5. So let's see where that leaves us. Don't forget that the negative is still there. That didn't cancel. So we're left with negative 1 on top, and then we have 2 x minus 1 in the denominator. Now after all that work, I think we can finally use substitution. Let's take 5 and plug it in for x here. So we're going to get negative 1 over 2 times 5 minus 1. So 5 minus 1 is 4, and 4 times 2 is 8. So our final answer is negative 1/8. But actually, we're not done. Because if you read up here carefully, it says find the equation of the tangent line. We haven't found the equation of a line. All we have found is the slope of the tangent line, actually. So what we need to do is we need to find a point. We have our slope. We just need a point now. Well, actually, I already know part of the point. I know that the x-coordinate is 5. So to find the y-coordinate, why don't I take 5 and plug it back in over here? In fact, we did that earlier, and we got 1/2, if you recall. So this is our point here. Now remember, I found this by taking 5 and plugging it in for here. So I got 5 minus 1, which is 4. 2 over 4 reduces down to 1/2. All right, now I'm going to use point-slope form, which looks like this. I need a slope and a point, and I can plug it in here. x1 and y1 is our point up here. M is our slope right here. So I just plug everything in. It's going to be y minus 1/2 equals our slope, and then x minus 5. And that is the equation of our tangent line. All right, it says find the slope of the tangent line of f of x equals the square root of x plus 4 at x equals 16. This time, I'm going to use the other difference quotient. This is the one you're probably most often going to see. In fact, it's possible you won't even see the first one. You'll only see this one. They both do the same thing. They allow you to find the tangent lines at points, but they're just written out differently. So let's go ahead and let's use this one and see how it works in this problem. You'll notice that up in our equation here, we have f of x. Well, I have f of x right here, so I know what that is. Then there's an f of x plus h. Well, what is that? That's up to us to figure out. So let's come here and let's see if we can figure out what f of x plus h is. Well, all this really means is take x and replace it with x plus h. So let's do that. There we go. Now, if this was to a power, like if this was squared or cubed or something like that, I would tell you to expand everything and combine like terms. But here, this is just a radical, and there really isn't very much to do. So I'm going to take these two and plug it into the formula up there right away. So the limit as h approaches 0 of our first piece, the square root of x plus h plus 4, minus our second piece, which is the square root of x plus 4, all over h. All right, remember your limit training. When you see square roots, you have to multiply by the conjugate. So let's do that here. Let's multiply by the square root of x plus h plus 4 plus the square root of x plus 4. Now remember that when you're multiplying by the conjugate, the first piece and the last piece have to stay the same. It's only the middle sign that changes here. So don't go around trying to make this like x minus h minus 4 or something like that. That has to stay the same. Okay, now when we multiply this out, we're going to FOIL it out. And when you multiply by the conjugate, every single time, the middle pieces will cancel out. So there's a little trick you can do to save some time. Multiply the first piece by the first piece, and the last piece by the last piece. So let's do that here. Square root of x plus h plus 4 times the square root of x plus h plus 4 is x plus h plus 4. Then we have the square root of x plus 4 times the square root of x plus 4 is x plus 4. And actually, because of the negative sign here, it's going to be a minus, just like that. Okay, now in the denominator, I could distribute this h out, I should say. But we're not going to do that. You always want to leave the other side unmultiplied. And you'll see why here in a second. Whew, okay. Now, you need to be really careful when you're doing these problems. For example, when you're writing this out, you might just write minus x plus 4. But that's wrong. It has to be minus the entire piece here. In other words, we have to make sure to distribute this negative sign to both of these pieces here. So when I do that, I'm going to get a negative x and a negative 4. And hey, look at this. I have an x and a positive 4 here. So what that means is this x will cancel with that x, and this 4 will cancel with that 4. Ah, how fortuitous. Leaving us with just the h. Okay, now this h will cancel with that h there. Whew, okay, let me take this and rewrite it up here, and let's see where that leaves us. All right, our h is canceled, so that just leaves us with a 1 in the numerator and this in the denominator. So now we can finally use substitution and plug 0 in for h. Let's see what we get when we do that. Okay, we're going to get the square root of x plus 4 plus the square root of x plus 4. Or in other words, we're going to have 2 square root of x plus 4s. All right, now we still haven't found the slope of the tangent line yet. What we need to do now is take 16 and plug it in here. So let's do that. We're going to get 1 over 2, the square root of 16 plus 4, which is going to give us 20. This right here is the slope of our tangent line. Now, you may or may not need to do this, but I am going to rationalize this. So let's multiply the top and the bottom by the square root of 20, and let's see if we can reduce it as far as we can. So we're going to get the square root of 20 over 2 times 20, which is 40. And then the square root of 20, that can be reduced further because 20 is actually 4 times 5. And 4 is a perfect square. So I'll get 2 root 5 over 40. And then 2 over 40 can be reduced down a little bit further. And I would say this is our final, fully simplified answer. This problem says, find the equation of the tangent line of f of x equals sine of x at x equals pi over 2. Now let me tell you, this one is quite a doozy. I even have some notes here just to make sure I don't make a mistake. Along the way, we're going to need to know a couple of trig identities, and you need to know these two limits up here in order to answer it. So let's dive in here. In order to find the equation of the tangent line, we're going to use this formula up here. So we're going to find the limit as h approaches 0 of f of x plus h. So f of x is sine of x. that means f of x plus h is sine of x plus h, minus f of x, so minus sine of x, all over h. Okay, now right here we have the sine of x plus h. We can actually expand that. You might have to do a quick refresher on that one, but there is a formula for expanding it, so let's do that. We're going to get sine x cosine h plus cosine x sine h. Now that was just this part being expanded. Let's not forget that we have a minus sine x at the very end here, all over h. Okay, now what we're going to do is we're going to start rearranging things. What my goal is to make this look like these two formulas. And you'll see that that actually will happen as long as I rearrange them in the correct way. So let's start with this. I'm going to first move these two pieces here and here, which is okay to do. When you're adding two things, you can swap their places and it doesn't change your answer. I'm also going to do one other thing too. So take a look. Okay, if I swap their places, this is going to be cosine x sine h, and then this is the other thing I'm going to do. I'm going to put this first part over h like this, and then I'm going to keep going here. So this second part is going to be sine x cosine h minus sine x. Now this is okay to do because these still have the same denominator, and I could just add them back together again and get what I had up here. But you'll see why I'm doing this in a second here. All right, let me move things around just a little bit more here. For example, on this first piece, let me take this cosine and let me write it in the front like this. Then over here, notice that there is a sine x and a sine x. So I'm going to factor that out. And just like I did here, I'm actually going to put it in the front of the rest of the pieces. So we're going to get sine x here, and then cosine h minus 1 all over h like this. Okay, now just by rearranging things, I'm able to actually use these two formulas here. Take a look. I have cosine x sine h over h. Well, recall, we're trying to let h go to 0 here. This cosine x here does not have an h in it, so we actually don't have to worry about it. Take a look here. We have sine h over h. Well, the limit as h approaches 0 of sine h over h, that's the same thing as up here. The only difference is that up here we're using x's and here we're using h's, but that's okay. So that means this is 1. Then take a look over here. Just like over here, we have the sine x in the front, which I don't have to worry about because that has an x and the limit is letting h go to 0. Over here, we have cosine h minus 1 all over h, which looks extremely close to this one. In fact, believe it or not, it is okay for me to swap these two places on this particular limit and still get the same answer, which is 0. Okay, so if this part is 0 over here, that means 0 times sine of x is 0. And if this part is 1, that means 1 times cosine x is just cosine x. So that means that all this work that we just did here was to figure out this answer here, cosine x. All right, it's time to finish the problem off. They wanted us to find the equation of the tangent line. In order to find the equation of the tangent line, we need the slope. So let's plug x equals pi over 2 in down here. That will give us the slope of the tangent line. The cosine of pi over 2 is 0. So here's our slope. Now we need a point. Well, I do know the x-coordinate of our point. It's pi over 2. Here's our point. In order to find the y-coordinate, I need to take this and plug it back into our function. So it's going to be sine of pi over 2. So let's do that up here. Sine of pi over 2 is equal to 1. So that's the y-coordinate of our point. Now that we have the slope, now that we have the point, we can plug this into point-slope form and we can get our answer. So we're going to get y minus 1 equals our slope, which is 0, and then x minus pi over 2. Now 0 times anything is just 0, and then what I'm going to do is add the 1 to the other side. This is our final answer here. If you can believe that, all the work we did was just so we could get y equals 1. This problem is very similar to the last one. It says, find the equation of the tangent line of f of x equals cosine of x this time at x equals pi. Now, just like the last one, this one is quite a journey. That's because we're going to need to expand things and move things around in order to make it look like this. So let's begin. We're going to find the limit as h approaches 0. Then we need f of x plus h, which is going to be cosine of x plus h, minus f of x, so that's minus cosine x, all over h. Now, this cosine of x plus h can be expanded, so let's do that. We're going to get cosine x cosine h minus sine x sine h. Now that part is just this first part right here. Let's not forget we have a minus cosine x at the end here. All over h. All right, just like last time, I'm going to move things around. This time what I'm going to do is I'm going to swap these two places, and I'm going to split this fraction up, just like I did in the last one. So let's see here. We're going to get cosine x cosine h, then minus cosine x. Here's our first split up fraction. And then I'm moving that over here, so it's going to be minus sine x sine h over h. All right, just like last time, I'm going to move things around even more. For example, on these first two pieces here, there's a cosine x and a cosine x. So I'm going to factor that out and move it to the front here. Let's see here. If I take a cosine x out, it's going to leave me with a cosine h minus 1 over h. I'm going to take this sine x over here and just move it to the front like this. Here we go. This is perfect. Because, take a look. I have cosine h minus 1 over h, and I have sine h over h, and we're letting h go to 0 here. That means that this piece here is 0, and this piece here is 1. Don't forget, it is okay for these two pieces here to be swapped and still get 0. That is legitimate. Okay, so we have 0 times cosine x, which is just 0, and then we have 1 times negative sine x, so what we end up with is negative sine x. Whew, all that work just to find this. But we're not done. We have to find the equation of the tangent line. So let's plug pi into this answer that we got down here, and that will tell us the slope of our tangent line. Let's see here. The sine of pi is 0. Negative 0 is still 0. So here's our slope. Now for our point, I do know the x-coordinate. It's pi. Let's go ahead and plug that into cosine of x and see what we get. That should be negative 1. So that right there is our point. Now let's plug it into point slope form and see what we get. We're going to get y plus 1 equals our slope, x minus pi. Now 0 times anything is still 0. And so the only thing left for me to do is to subtract 1 from both sides and get y equals negative 1. That is the equation of the tangent line of cosine of x at x equals pi. If you found this video helpful, you might consider checking out my website, which is linked in the description below. You'll be brought to Infinity Learning Academy, where you can find Cruising Through Calculus. At Cruising Through Calculus, we have over 100 videos and documents to help you get through your calculus class, including videos for each topic, practice problems, and full video solutions for those practice problems. I hope to see you there, and together we can cruise through calculus.